So let's look at the definition or at one part of this RFC covering generic threads routing protocols. I could now just read it down, but everybody can maybe read it itself. It ends up in two attacks. It's one kind of attack is the traffic redirection, but in a larger scale, a typical let's say, for example, an ARP spoofing attack redirects traffic between two hosts, or maybe between a subnet and a host. If you attack routing protocols, you can redirect whole networks, and not only traffic for single hosts. And when you do nasty things with routing protocols, of course, you can perform denial of service attacks. So if you manipulate the routing information so it can't work anymore, so that's a kind of denial of service in general. So what you can do with routing protocols is inject incorrect routes, so which will happen in the traffic being directed to the wrong routers, not to the routers they should go to. So maybe it could be your laptop and you forward it to the real router, so you can eavesdrop the traffic, do man-in-the-middle attack actively, all that stuff that needs traffic redirection as a basis. Yeah. So that are mainly the bad things that can happen. Traffic redirection with eavesdropping or man-in-the-middle attacks and denial of service attacks. So then let's go to the first protocol and the first demonstration we have. OSPF stands for Open Shortest Path First. As I already told, it's one of the most widely used routing protocols inside corporate networks. It also belongs to the category of the link state protocols. I already told you this also. If the routing injection, so what we will try to do is inject or redirect a route, which should, the packets for a network should end up at a special router. We redirect it over our laptop, so we are able to eavesdrop the traffic or do man-in-the-middle attacks, stuff like that. If this will work actually in an OSPF network, I won't dig too deep into the OSPF theory now, but if you have an OSPF managed network, the different networks known inside the OSPF network can have different types. So, and there are some types of networks, for example, the so-called totally stubby network, which is a network which only can have one router. So all systems on this network only have a default route. It's not possible to inject other routes. The OSPF router won't accept this in general, but that's by design, so you can't perform attacks within such a network. But nearly every other type of network will work. There are also some protection mechanisms which should prevent false routes from being injected. One is the so-called OSPF fightback mechanism, which mainly is a feature if, let's say, I have an OSPF-enabled router called router A, and it receives some routing information telling the router, hey, I can reach this or that network, but this router is responsible himself for that network, so he knows, hey, there's something wrong. So he will re-inject the route himself and prevent the redirection. But that, in most cases, that does not really protect against false route injection. So it's mainly against misconfigured routers that are added to the network. So that's the point where the first demo will take place. We have a network setup. It's pretty simple. It's two routers connected with one network in the middle of them. Let's say it's a backbone network, and we have an attacker, this laptop, sitting in the middle and fiddling around with the routing protocol to redirect the traffic. But then you will tell the details about the demonstration.
Okay, what you see here now is the command line of one of the two routers you see in the front here. And what I will do first is show you the routing table, which looks like that. Okay, we got some routes into the 192.168 net. We got some 172.16 routes, but don't mention all the different routes. The important thing is that you don't see any, let's say, 10.0 network. So if there were a default route, all traffic going to the 10.0 network will follow that default route. Okay, so there is no route into 10net. I think we should change this because I want to be the 10.0 network myself. So what I will do is just launch up Loki, which is this nice tool. So, and now I will just select an interface. I will listen to, I've prepared different demos on the same setup, so you will see some VLAN configs here, and I got different IP addresses. So, but for that demo, I need my real ETH0 interface, and when I click on OK, the tool will just start listening for packages on that interface. So, and you see there are some of these tabs blinking, so it also discovers some routing protocols, which in this case is OSPF, because this is the OSPF demo, yeah, obvious. Okay, so we got two hosts speaking OSPF in that network. So, okay, let's just hook up to them. I will just change the authentication to none, as they are using non-authentication, and afterwards I'll start participating into the OSPF process. So I'm just starting to send out hello packages, and when one of these routers see my hello packages coming in, they will perform the OSPF handshake with my tool. And once I'm in the state full, I got all the routing information from that routers delivered via OSPF. So you see that are all the routes those two routers exchange between each other. There are some different kind of routes, as René mentioned. There are some stub networks, there are transit networks, there are point-to-point links, but there is no totally stub network. So it looks like we're in quite a good position to perform an injection attack. So what I do next is just go to the injection tab and type in, okay, as said, I want to show up a 10 network. Let's say it's a square 16, and okay, it's a route link, so it's directly connected to my router. I'm not really a router, but I'm telling all the OSPF router, okay, I got a link into the network. So once I add this route, the link state update gets thrown out to the OSPF routers, and yeah, in a second or two you will see right there is my route showing up. So the router is just repeating that information to me, saying, okay, I understand you, I know there is a route into the 10/16 network. And when we look back into the router's command line, you will mention there is, okay, some new OSPF neighbor showing up, which means I successfully performed the whole OSPF handshake. I'm now part of the OSPF network. And if we take a look at the routing table afterwards, you will see there is a new route showing up for the 10/16 network, which points to my local notebook. So every packet which should be routed into the 10/16 network is now redirected to my notebook. And I can do with that traffic whatever I want. I can sniff it, I can perform man-in-the-middle attacks, I can just redirect it to some other router to keep the traffic in flow, to get the traffic to its final destination. But the important point is I will get all that traffic. Okay, so that's the first part. René will now continue with the next protocol.
So this is which Daniel just injected a new route into the routing tables of the participating routers. Which, if you do it in both directions, advertises a new route to that router, and a network originally based behind that router to the other direction. So every traffic between these two networks will be redirected over the attacking system. In this case, it's a notebook, so you can do with the traffic whatever you want. So the next thing is same thing with the enhanced IGRP protocol. I already told you it's a distance vector protocol, but it's still used in some locations. I call the locations, let's say, Cisco shops. So companies really sticking to Cisco, buying the switches there, the routers there, every equipment there. So there's a good chance they're using enhanced IGRP as a routing protocol. You can do that only if there's no need for interoperating with other manufacturers. So because other manufacturers won't speak enhanced IGRP with you. If you have a mixed environment, you can't use that protocol. But in plain Cisco environments, you will still find the enhanced IGRP protocol. Yeah. There were also some security discussions back in 2005 about security in enhanced IGRP managed networks, but since then, at least I don't notice anything more happening on that topic. There was no tool being able to perform these attacks, which were discussed there. That's also another reason why we implemented that or mainly Daniel implemented the stuff in Loki. And now you will see a similar demonstration to the OSPF demonstration, but just using another routing protocol. So,
okay.
Down to the next demo.
Let's switch over to my notebook again. So that's still the same routers command line interface. When we take a look at the routing table again, you will see there is no route to the 10/16 network anymore because I disconnected my tool and the OSPF state just shut down, so also the route got deleted.
Yeah, and this letter indicates where the route's coming from. It's connected, it's OSPF, and later we'll see the outside GRP.
Okay, so let's launch up Loki again. And this time I will start sniffing on a different interface, which is just another VLAN on the setup. And in this VLAN there is no OSPF spoken, but you see it just discovered some routing protocol, which is the enhanced IGRP. Okay, we see there are two hosts speaking enhanced IGRP. They're both in the autonomous system 1, so they're part of one routing infrastructure. The first thing I have to do is participate in this enhanced IGRP autonomous system. So I have to send out hello packages again, and both router will perform some kind of handshake with my program. You see in the background, okay, there is a new enhanced IGRP neighbor showing up, which is my notebook, and you also see there are routing information delivered by the two routers. So now I have to choose, either I want to inject an internal route or I want to inject an external route. I will just do the same as the demo before. So I will configure an internal route which just points to my notebook, which is this IP address. I also decide to take /16 network, and my destination again is the 10.0 network. So I will inject this route into both routers, so I have just to mark them and afterwards sending out those updates. So you see one of the routers instantly repeat that routing information to my system. And if we have a look on the routing table, oh, that's the wrong one, sorry. So if we take a look on the routing table, you see there is a new route showing up to the 10.0/16 network. So we also successfully injected some fails routing information into that routing process. So again, all traffic to the 10/16 network will be redirected or routed to my host. And I can do whatever I want with that traffic. Okay. So back to Rennie and the next demo description.
Okay, so we are just walking through demonstrations now. There are some routing protocols, like OSPF has a feature like that. That's because I'm going to tell you about that feature here. Some routing protocols have some authentication features. So there, like for OSPF, there's some shared key, a password you have to know to be able to inject routes because the routing information will be authenticated. not a lot of networks